In this screencast, we are going to look at polyatomic ions. So if we take this word apart, we know that the prefix poly means many, and atomic refers to ion or to atoms, and ions means that it's an atom or a group of atoms that has a charge, either positive or negative. So a polyatomic ion is a group of atoms that are bonded together by covalent bonds and overall carry a charge. An example of a polyatomic ion would be something like NH4 plus 1. So what this tells me is that my grouping of atoms is 1 nitrogen and 4 hydrogens, and this grouping of atoms overall has a +1 charge. So we're going to be looking at how many electrons are involved in the structure, but because it has a +1 charge, that means that an electron has been removed. So it has 1 less electron than what it should have. So let's take a closer look at these. So polyatomic ions are certain atoms that are bonded covalently with each other, and they form a group of atoms that has both molecular or covalent and ionic characteristics. And this collectively charged group of bonded atoms is known as the polyatomic ion, which can have either a positive charge or a negative charge. So like other ions that we've dealt with, polyatomic ions have a charge that results from either a shortage or an excess of electrons. So that's what gives it the positive or negative charge. An example of a polyatomic ion is the ammonium ion, which from the beginning of the screencast I said was NH4, and it has a +1 charge. So you want to remember, to get an ion, we change the number of electrons. So typically in a neutral atom, protons is equal to the number of electrons. But in an ion, they're not equal. They're different. And we can't change the number of protons. We can only change the number of electrons. So to end up with a positive charge, electrons have to be lost. Okay? So if we look at the ammonium ion, nitrogen has 5 valence electrons. Hydrogen has 1 valence electron, but there are 4 hydrogens, so we're going to add 4 valence electrons. So the 5 plus 4 gives us 9 electrons, but in order for it to have the +1 charge, we have to have lost 1 electron. So instead of having 9 valence electrons, it's going to have 8, which is less than what it should have. So that's what gives ammonium its +1 charge. So as it describes down here at the bottom, the 5 protons in the nitrogen atom plus the 4 protons in the 4 hydrogen atoms give the ammonium ion a total positive charge of +9. But because it's got an overall +1 charge, we lose that 1 electron, giving it a total of 8 electrons rather than the 9. So let's look at some examples of polyatomic ions. So we're going to start with ammonium, which is the one we've been working with. And again, this one has nitrogen. And nitrogen has, there's 1 atom, and it has 5 valence electrons. And there are 4 hydrogens, so we take 4 times the 1 valence electron, which gives us 4, so that means we should have 9 electrons total. But because this ion has a +1 charge, we're going to get rid of 1 electron, giving us a total of 8 electrons. So if we count them, we have 2, 4, 6, 8 valence electrons. In the nitrate ion, we have nitrogen again, and there's only 1 of them, so we have 1 times its 5 valence electrons, which gives us a total of 5. And we have 3 oxygens, okay? And each of those oxygens has 6 valence electrons, so 3 times 6 gives us 18. When we add them together, we get 23 valence electrons. But this -1 charge tells us that we need to add 1 more electron, giving us a total of 24 electrons. So let's count in our structure here. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24 electrons total. Finally, in the sulfate ion, we have a sulfur, just 1. So we take 1 times 6, because sulfur has 6 valence electrons, and we have 4 oxygens. So here we're going to take 4 times 6, which gives us a total of 24 electrons. Now this -2 charge up here tells us that we now have to add 6 plus 24 gives us 30. We have to add 2 more electrons to that, so our final diagram should have 32 electrons. So let's count and see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32 electrons in our Lewis structure. So when we're drawing the Lewis structures for polyatomic ions, we follow the same rules that we did before. So we're looking at the elements that make up the ion, how many atoms of each element there are in the polyatomic ion. We have to figure out how many valence electrons our atoms should have. The only thing that's different now is that we have to take into effect what is the charge on the polyatomic ion. If our charge is positive, then we're going to remove electrons. And if our charge is negative, then we're going to add electrons to the total number that we have in our structure.